So, hello everyone. Welcome to Krishna's Online Lectures course Creel. So, Krishna's Online Lectures was the previous name of this channel, and now it's become course Creel. So, I have combined the name. That's why it is a bit long. Krishna's Online Lectures course Creel. So, welcome you all in this new session of Kinematics of Machine. We are going to learn about velocity and mechanism. We are going to learn about the instantaneous center method in today's class. So jaldi jaldi sab join ho jaiye. So I'll wait for few seconds or few minutes for my learners to join. Then we'll start the session. तो इस सेशन को स्टार्ट करने से पहले देखो कोर्स क्रिल के बारे में तो मैं काफ़ी कुछ बता चुकी हूँ पहले भी जो हमारी प्रीवियस क्लासेस हैं तो कोर्स क्रिल में देर आर सो मेनी कोर्सेज अवेलेबल विच इज़ रिलेटेड टू डिफरेंट कैटेगरीज ऑफ एजुकेशन सो जस्ट चेक आउट द कोर्सेज and in whatever course you want to enroll yourself you can enroll by paying a very nominal amount of fee. We are providing very affordable courses in different categories of education. Our AutoCAD, StatPro, SolidWorks, these courses are performing very well. So just check out the courses which is related to technical field or which is related to skill development. And there are so many other courses which is related to non-technical field or competitive exams like banking, UPSC, PSC. So there are so many courses available. Basically, we have geography, complete course of geography for the UPSC and PSC. We have the course of science for UPSC and PSC. So these courses you can check and you can buy at very nominal cost. And these courses are prepared by the experienced faculty. So you will not get any kind of problem while learning with these courses. So this is about the website, and we have an app also, so you can download the app, and same courses is available in app, but in app there are some more courses like test series are available, which are available on app only, not on the website. So test series mein mechanical, civil, chemical, computer, electronics, electrical, there are so many test series available for each and every branch. So just check out the test series for your related branch. So sorry. So this is about the course Creel. Now just give me a moment. So I'm just checking whether people are joining or not. Some people have joined already. Yeah, we are live and okay. Okay, so people are joining. Hello everyone. So let me put on vibration mode. Okay. चलिए अब सेशन स्टार्ट करते हैं बिकॉज अभी देर नहीं करते हैं बिकॉज जो हमारा कोर्स है इट्स क्वाइट लेंदी तो इसको जल्दी जल्दी ख़त्म करना है बिकॉज इट्स अ क्रैश कोर्स सो वी विल स्टार्ट विद द मेथड ऑफ डिटरमाइनिंग द वेलोसिटी ऑफ अ पॉइंट. अभी लास्ट क्लास में हमने बहुत ही बेसिक चीज़ें जो है विच इज़ रिलेटेड टू वेलोसिटी ऑफ मैकेनिज्म वो डिस्कस की थी. सो वी हैव डिस्कस्ड अबाउट द बेसिक टर्म्स like instantaneous center. Suppose if any object is in translation and rotation both, so we will consider pure rotation and that object will rotate about one center if it is continuously in motion in rotational as well as in translation. जैसे wheel की अगर हम बात करें तो wheel is continuously in rotation. और किसी vehicle की wheel की अगर हम बात करें तो wheel जब vehicle चलता है so wheel is in continuously in rotation but simultaneously it is changing its position longitudinally also. So the center position along the longitudinal direction is continuously changing. It is in rotation but the center position is continuously changing. So instantaneous center, if we are considering any object which is in pure rotation. So about the point that object is rotating is called instantaneous center. And the instantaneous center, if an object is continuously in motion along the longitudinal axis, so the position of instantaneous center is also changing. Okay, so or if it is having apart from the translation, if it is having other kind of or curvilinear motion also along with the rotation, so in that case also the center of position of the instantaneous center is continuously changing. Okay, there will be one center for the rotation, but that position along the मोशन मतलब जिस भी डायरेक्शन में मोशन हो रहा है, चाहे वो कर्वीलिनियर कर्व में के अकॉर्डिंगली मूव कर रहा है अपनी पोजीशन, जितना भी डिस्प्लेसमेंट हो रहा है, ओके, सो इट इज रिलेटेड टू डिस्प्लेसमेंट आल्सो. सो जितना भी डिस्प्लेसमेंट हो रहा है पर्टिकुलर पॉइंट पर उस सेंटर की पोजीशन विथ रिस्पेक्ट टू डिस्प्लेसमेंट चेंज होगी. ओके, सेंटर देखो, सर्कल अगर व्हील घूम रहा है तो व्हील का सेंटर तो सेम होगा. ओके, दैट वी यूजुअली कंसिडर एज द इंस्टेंटेनियस सेंटर. बट जो इसकी पोजीशन जो है वो डिस्प्लेसमेंट के अलाउंग जो है वो कंटिन्यूसली चेंज होगी. ओके, सो हमने ये चीजें पढ़ी थी, हमने पढ़ा था इंस्टेंटेनियस सेंटर एक्सेस, वी हैव लर्नड अबाउट द एक्सोड, वी हैव लर्नड अबाउट द सेंट्रोड, वी हैव लर्न अबाउट द स्पेस सेंट्रोड, बॉडी सेंट्रोड. सो दीज थिंग्स वी हैव लर्न एंड वी हैव डिस्कस अबाउट द type of methods by which we can determine the velocity at a point in a mechanism, or if we are considering link, so velocity of a point in a link. Okay, so here we have discussed about the two methods. Just a second. So our first method was instantaneous center method. And another method was the relative velocity method. So we have discussed few points about the instantaneous center method. Instantaneous center method में हमने देखो डिस्कस किया था कि ये चीज मैं डिस्कस करूंगी. सो इट इज इंस्टेंटेनियस सेंटर मेथड जो होता है, देखो इंस्टेंटेनियस सेंटर क्या होता है. इंस्टेंटेनियस सेंटर, सपोज इफ एनी ऑब्जेक्ट is in or suppose if we have any link, okay, so that link, suppose अगर हम एक point की बात करें यहाँ पे, suppose इस link पर हमारा ये जो point है, it is in continuous rotation. In that case, about a point, that particular point is rotating. Okay, so that point about which that point or that link is rotating is called instantaneous center. ओके, तो इसको हम एक सेंटर की तरह ही कंसीडर करेंगे. ओके, सो लोकेशन कैसे निकालते हैं वो मैं डिस्कस करूंगी अभी. सो इंस्टेंटेनियस सेंटर जो है मैंने लास्ट क्लास में डिस्कस किया था. Now here, if we want to define the number of instantaneous center for the mechanism, okay, तो mechanism में तो number of links होती हैं, number of pairs होते हैं. Okay, so mechanism is what, where one link is fixed, right? Suppose अगर हमारे पास n number of link है, number of links are n. In that case, if we want to define the number of instantaneous center, so it will not be equal to link or it will not be equal to pair. यहाँ पे number of links भी होंगे, number of pairs भी होंगे और number of joints भी होंगे. Okay, इस mechanism में. Okay, so if we want to define the number of instantaneous center, अगर हम capital N से define करते हैं, so it is equals to small n into n minus 1 divided by 2. So this number of instantaneous center is depends on the combination of links present, mainly number of pairs which are present in that mechanism. Okay, so that number of combination, maximum number of combination, basically maximum number of combination of links. maximum number of combinations of link is defined as number of instantaneous center. Okay, suppose if we have four links. Okay, so suppose if we have four links, so this is link 1, this is link 2, this is link 3, and this is link 4. 1 2 3 4. If it is a mechanism, so one link should fixed. So we have four number of links. So here we can define the number of links. Suppose हमारा small n है 4. So it will be 4 into 4 minus 1 divided by 2. So it will be 6. Okay, तो number of link will not be the number of instantaneous center. अब ये 6 instantaneous center कैसे आएंगे उसकी location मैं बताऊंगी. But here first I will discuss about the here this is the point. जैसे हमने यहाँ पे देखा मेथड ऑफ डिटरमाइनिंग द वेलोसिटी ऑफ अ पॉइंट. सो वेलोसिटी ऑफ अ पॉइंट ऑन अ लिंक बेसिकली वी आर गोइंग टू डिफाइन ऑन अ link, and simultaneously we will define the velocity of instantaneous point, instantaneous center of a link which is having velocity, different velocity at different end or different point. So here hope this thing is clear. So here how we can define the number of instantaneous center for the mechanism. Suppose if we have n number of links, so n number of link, एक link को हम एक center consider नहीं करेंगे या एक link के basis पे एक center हम consider नहीं करेंगे. Here we will define the maximum number of combination of links, and on that basis we will define the नंबर ऑफ इंस्टेंटेनियस सेंटर. सपोज देखो यहाँ पे जैसे हम अगर लेते हैं हमारा ये जो डायग्राम है, तो हमारे पास चार लिंक है. सो फर्स्ट टू लिंक्स आर 1 and 2. सो फर्स्ट हमारा इंस्टेंटेनियस सेंटर सपोज अगर हम आई से डिफाइन करते हैं तो 1 and 2 हो गया. सेकंड क्या है 1 and 4. सो आई 1 and 4 ले लिया. ठीक है 2 and 3 तो ये ले लिया हमने आई 2 and 3. अभी 3 and 4 तो ये हमने ले लिया आई 3 and 4. So here we have 4 instantaneous center. Now how many other combinations are we can define? The next combination which we can define between 1 and 3. So I 1 and 3, and other combination we can define as I 2 and 4. So this is how we can define 6 number of instantaneous center. Number of combination of link or maximum number of combination of link. अभी ये कैसे हुआ देखो 1 और 2 तो हम देख लेंगे. 1 और 2 तो एक पॉइंट पर मीट कर रहे हैं तो एक ये हो जाएगा. 2 और 3 एक पॉइंट पर मीट कर रहे हैं तो ये हो जाएगा. 3 and 4 are connected, 4 and 1 are connected, so we can define the center for this. But how 3 and 1 is interconnected and 2 and 4 is interconnected? Here there is no direct contact between 3 and 4 and 2, 3 and 1 and 2 and 4. So how we can define? So that is another type of instantaneous center which is continuously changing its position. Okay, so basically there are three types of instantaneous centers we have to learn. One is the fixed instantaneous center, second is the permanent instantaneous center, and third is the neither fixed nor permanent instantaneous center. तो ये जो दो combination है, these are neither fixed nor permanent type of instantaneous center. but इसके पहले हम यहाँ पे हमारा जो next जो basic part है how we can define the velocity of a point and how we can define the instantaneous center at a point, वो चीज जो है वो यहाँ पे पढ़ेंगे. okay, and this velocity of a point we will define on a link or we can define on a mechanism, because link जो है mechanism का एक part होता है. तो mechanism में number of links होंगी, but for one link we have to define velocity at a point. okay, so how to determine the velocity of a point? It is mainly defined by two methods. so हम यहाँ पर instantaneous center method का use करेंगे. okay, so instantaneous center method basically why we use. okay, so we usually define velocity of a point. okay, we analyze the motion Analyze the motion of link or mechanism, okay, on the basis of displacement. ओके सो इंस्टेंटेनियस सेंटर मेथड क्या है? इंस्टेंटेनियस सेंटर में हम एक सेंटर फाइंड आउट करेंगे. लास्ट क्लास में मैंने बताया था इंस्टेंटेनियस सेंटर कैसे हम मतलब क्या होता है, व्हाट इज द एग्जैक्ट डेफिनेशन ऑफ इंस्टेंटेनियस सेंटर. सो इंस्टेंटेनियस सेंटर मेथड में ऑब्वियसली वी हैव टू फाइंड आउट द इंस्टेंटेनियस सेंटर. along with that we have to find out the velocity or as well as displacement of that particular link. okay तो अगर हमारा link जो है if it is in motion, so about which point that motion is in rotation. basically हम यहाँ पर pure rotation ही consider करेंगे. अगर ट्रांसलेशन या रेक्टिलिनियर मोशन है सो देयर विल नॉट बी एनी सेंटर. सेंटर के लिए हमें क्या कंसीडर करना पड़ेगा? सेंटर के लिए हमें कर्विलिनियर मोशन कंसीडर करना पड़ेगा. and in terms of curvilinear motion we have to define the rotation also for that for any particular object. okay तो यहाँ पर instantaneous center method जो है it is analyzing the motion of the link and that motion we will consider as pure rotational motion. Link or mechanism both we can consider, but the motion will be pure rotational motion about a particular point on the basis of displacement, and that point will be our instantaneous center. So here we have to define the instantaneous center as well as we have to define the velocity of a point and about which that point we have to define the velocity and that point is moving with respect to one point, that also we have to determine. okay तो यहाँ पर हम start करते हैं. so let's okay so here we are you can see there is a diagram. okay so here we have we are considering a link. so suppose this is the link, this is point A and this is point B on the link. okay so let us consider 2 points. Let us consider 2 points on link. Just a second. If you have any doubt, please let me know. ओके चलो अभी तो कोई डाउट एज सच आया नहीं बिकॉज हमने लेसन स्टार्ट किया है. okay so consider 2 points. we are considering 2 points on a link. suppose here we have this link, you can see this link, and there are 2 points on the link. my throat is not well yet, so there will be a disturbance between the class. okay so we are considering 2 points on link A and B. okay and suppose both the points are in motion, as we are considering that link is in motion. okay mechanism है तो links जो है वो motion में होगी. one link will be fixed and other links will be in motion. so suppose this link is in motion and we are considering 2 points A and B, so and both the points are in motion. okay so suppose the point A is having velocity. अभी देखो जरूरी नहीं है कि जो भी पॉइंट है लिंक के वो सारे सेम वेलोसिटी फॉलो करें. okay so suppose at one particular point A, if we are considering velocity, so the velocity of point A, let us consider VA, and this is the direction of velocity of point A. okay so we have to define the magnitude and direction of the velocity. okay so velocity at point A is VA, and suppose if we have both magnitude and direction of the velocity at point A, and now let's see VB. So this VB is having only direction. Okay, so this is VB. Okay, so velocity at point B is VB, right? So velocity at point B is VB and it has direction only. So suppose here it has only direction. So we need to find out the magnitude of velocity at point B. Okay, तो हमें magnitude VB का जो है वो find out करना है, right? So here we are considering 2 points A and B on a link, and the velocity is at point A is VA, which is known in magnitude and direction, and at point B we are having velocity. This is the direction of velocity of point. This is the direction of point B, which is known in direction only. So we have to find out the magnitude of this. Okay, and this direction of VA and VB is defined by two angle. Basically direction जो है वो हम define करते हैं with the help of angle. So suppose the direction of VA we are defining with respect to this link is alpha, and for this suppose let's consider the direction of VB is defined by beta. Okay, so I'm not going to write here. So direction usually we define in terms of angle. So for VA, the direction is defined by alpha, and for VB, the direction is defined by beta. Okay, now we have to define the magnitude of VB. So how we will define? So what we will do, we will draw a perpendicular on these velocity vector. Okay, so here at point B, we will draw a perpendicular which is perpendicular to this VB, and at point A we will draw a perpendicular which is perpendicular to VA. Okay, so this line is perpendicular to VA and this line is perpendicular to VB. Okay, so this should be 90. Okay, थोड़ा सा dislocation है, but ये वाला जो angle है ये consider करना 90 है. Okay, so this is 90 and this is 90, right? Now the intersection point we are considering as the point of rotation of this link AB. Okay, so this particular point we will mark as instantaneous center I, right? So here we will mark I as the instantaneous center about which the point A and B both are having pure rotation. Okay, so in whatever direction we can define, suppose this is the direction we are defining. So in this direction we are considering the pure rotation. Okay, so here we have marked the instantaneous center I. Now we have AI and BI. So AI and BI, okay, both are perpendicular to VA and VB, right? So hope this thing is clear. Okay, so we have marked the intersection point I. Now here you can see the point A and B both are on the same link. Okay, so A will have relative motion with respect to another link or with respect to another point, but that should not be on the same link. And B can have relative motion with respect to another link or another point, but it should not be on the same link. With respect to point which is on the same link, these 2 points will not have any relative motion. It means A and B will not have any relative motion with respect to each other. Okay, तो A और B एक दूसरे के अबाउट कोई मूवमेंट नहीं करेंगे. They can move in different direction with respect to other. Okay, but they will not move with respect to each other. मतलब A और B जो है दोनों एक ही rigid link पर हैं, so they will not have any kind of motion, relative motion. They will not have any kind of relative motion. Now, if we resolve the velocities of point A and B, in that case, how we will resolve? If we resolve the velocities, so velocities will be Just a second. Okay, chalo. So let's resolve the velocity along AB. So how many velocities we have? So along AB we have to resolve. Okay. So along AB we have to resolve. So in this direction we have to resolve. Right. This. So we have to resolve this particular component for the velocity along AB. Okay. Along AB. So it will be VA and it will be cos alpha. Right. And along AB, we have to resolve the velocity at point B. So it will be VB cos beta. And both are on same link. It will not have any relative motion with respect to each other. So both should be equivalent. राइट अगर हम यहाँ पे इस डायरेक्शन में वेलोसिटी कंसिडर करते हैं सो इट विल बी सेम ओके और या फिर जो भी कंपोनेंट्स आएंगे बोथ द कंपोनेंट it should be equivalent. Okay, so if we are resolving the velocity along AB, so it should be VA cos alpha equals to VB cos beta. Okay, now if we can write down this as VA by VB, that is the ratio of velocity, that is cos beta divided by cos alpha. Now we can further simplify this. It will be sine 90 minus beta divided by sine 90 minus alpha, right? So this is the ratio of velocity of point A and B. Now here we have a triangle AIB. You can see this is the triangle we have AIB. So this is alpha. So this is 90 minus alpha. This is beta. This is 90. This should be, okay, this is 90 minus alpha. This is 90. Right. Okay. So here we have the angle. So suppose this is the this is 90. This is 90 minus alpha. So this should be 90 minus beta. Right. Okay. So here we have defined all the angles. So this is alpha. So this angle will be 90 minus alpha. This is 90. This is beta. This is 90 minus beta. Okay. So this angle will be 90, right? So here we have triangle AIB. Okay, so if we have this triangle, so we can apply the Lamy's theorem here. So as per Lamy's theorem, we can define another equation. Okay, अगर हम यहाँ पे Lamy's theorem apply करते हैं, so as per Lamy's theorem, we can define the term as AI divided by equals to BI. Okay. So it will be AI upon sine 90 minus beta and equals to BI upon sine 90 minus alpha. Right? कैसे? देखो 90 minus alpha in front of this. So it will be BI and 90 minus beta in front of this. What it is? AI. Okay. And in front of 90, we can define AB. Okay. So AB equals to sine 90. So AB divided by sine 90. Okay, so here we are considering only two terms. Okay, so here AI divided by sine, okay, AI by BI. Let's write down AI by BI. So AI by BI, that is equals to sine 90 minus beta and divided by sine 90 minus alpha. Okay, suppose this is equation 1, this is equation 2. So both the equation can be equivalent. So we can write down this term as VA divided by VB equals to AI by BI. So it will be VA by AI. So VA by AI, that is equals to VB by BI. And suppose if we are considering any third point in between, just give me a moment. So if we want to define the third point velocity also, so it can be VC by CI. VC by CI. Okay, but here we are considering 2 points only. Suppose we have 4 points, so it will be VD by DI. Okay, so whatever point we are considering, we will equate all the terms accordingly. Okay, so here we have, so this V by AI is representing what? It is representing as the angular velocity. Okay, V by R, right? V by R. AI is what? AI is what? The point A is rotating about a center I. So this AI will be radius, and this point B is rotating about center I. So VI is the radius. So it will be equivalent to what? It will be equivalent to omega. So VB by VI will be also equivalent to omega. So in this particular manner, we can define the velocities. Okay, so with the help of this equation, we can define the velocity. VA, we have AI, we can define BI, we can define in terms of radius, and VB is unknown. So the magnitude of VB we can define with the help of this particular equation, or VB we can define with the help of this particular equation if we have angular velocity. Okay, so omega is the angular velocity, right? So by this way we can define the magnitude, and here this VA is inversely proportional. Distance of a point from instantaneous center. So as per this equation, we can define the VA will be inversely proportional to the distance of point from the instantaneous center. Similarly, VB will be also inversely proportional to distance of a point from the instantaneous center. Okay, so by this way, we can define the velocity at a point on a link, right, with the help of instantaneous center method. Okay, so here we can define few properties of the instantaneous center. Instantaneous center okay, so instantaneous center जो है, suppose if we are considering instantaneous center for link AB, okay, so AB, point A, B, or suppose there is a third point C, there is a fourth point D. So instantaneous center will be common for each and every point if this instantaneous center is we are considering for all the point which is lying on the same link. Okay, so the rigid link rotate instantaneously with respect to one instantaneous center in a particular direction. Okay, and two rigid link will not have linear velocities. Okay, two rigid links will not have linear velocity if we are considering instantaneous center. It should have some amount of rotation if we want to find out the instantaneous center. Okay, so instantaneous center is completely depends on the rotation. Okay, so if anything which is in translation, so we cannot define the instantaneous center for that. Suppose if any object is moving on a flat surface, right, if any object is moving on a flat surface, so this particular object is not having any rotation. In that case, we cannot consider the instantaneous center for the linear motion. Okay, so here this particular link and this particular link should not be in linear motion, or should not be having translation. Okay, so instantaneous center here we will not consider, or we will consider at the infinite position. Okay, so for two links which are moving linearly to each other, relative to each other, or sliding motion is there, so the instantaneous center we will consider at the infinite position. Okay, so this is some terms which is related to instantaneous center. Now, and we have discussed about the number of instantaneous center method, right? तो यहाँ पर नंबर ऑफ इंस्टेंटेनियस सेंटर तो हमने निकाल लिए थे. होप एवरीथिंग इज क्लियर. सो नंबर ऑफ इंस्टेंटेनियस सेंटर तो मैंने यहाँ पे डिफाइन करने के लिए एक यहाँ पे फॉर्मूला बता दिया था. ओके, नाउ हियर वी हैव डिफाइंड ऑलरेडी 6 इंस्टेंटेनियस सेंटर्स. So 6 instantaneous center we can define in terms of all the possible combination of two links. Okay, all the possible combination of pairs, right? So here 1 2 1 4 2 3 3 4 1 3 and 2 4. Okay, so now if we want to locate these kind of instantaneous center, so here suppose we have 4 links. One link is fixed, right? So this is link 1. अच्छे से लिख देती हूँ. 1 and okay, this is not 1. Okay, it will take a lot of space, so I'm redrawing this. Okay, so here I'm going to redraw. So one link is fixed. This is our link 1, this is our link 2, this is our link 3, and this is our link 4, right? So how many combination we can define for these 4 links? For the in terms of instantaneous center, number of links are 4, and sorry, number of links are 4, and number of instantaneous center will be 4 into 4 minus 1 divided by 2, so it will be 6. So total number of instantaneous center if we want to define, so for 1 and 2 it will be I12, for 2 3 it will be I23, for 3 4 it will be I34, and for 4 1 it will be I14, and other two combination are 3 and 1, so I13, and 2 and 4, so I24, राइट. सो यहाँ पे हमने 6 इंस्टेंटेनियस सेंटर डिफाइन कर लिए. अब 6 इंस्टेंटेनियस सेंटर हम यहाँ पे डिफाइन कैसे करेंगे? ओके, सो हियर we will mark all the instantaneous center at the exact location. Okay, so suppose this link is having 4 turning pairs. Suppose here it is having 4 okay, 4 turning pairs, right? 4 turning pair. All the turning pairs are 1 and 2, 2 and 3, 3 and 4, and 1 and 4. तो 4 turning pair हैं. So instantaneous center for the turning pair we will mark at the joint only. For all the turning pair, ये हमेशा याद रखना, for all the turning pair the instantaneous center will be marked at the joint. Okay, तो यहाँ पर हम mark कर देते हैं I12, यहाँ पर मार्क कर देते हैं I23, यहाँ पे मार्क कर देते हैं I34, और यहाँ पे मार्क कर देंगे I14. सो 4 इंस्टेंटेनियस सेंटर मार्क हो गए हमारे. ओके, सो 4 इंस्टेंटेनियस सेंटर में से कौन कौन से टाइप्स ऑफ इंस्टेंटेनियस सेंटर्स हैं? सो द फर्स्ट टाइप ऑफ इंस्टेंटेनियस सेंटर इज फिक्स्ड इंस्टेंटेनियस सेंटर. ओके, so first type is fixed instantaneous center. Second type is permanent instantaneous center. Permanent instantaneous center. And third is neither neither fixed nor permanent. तो ये 3 तरह के इंस्टेंटेनियस सेंटर्स जो हैं वो हमें यहाँ पे डिफाइन करने हैं. तो फर्स्ट वी विल डिफाइन फिक्स्ड इंस्टेंटेनियस सेंटर. सो फिक्स्ड इंस्टेंटेनियस सेंटर इज व्हाट? वेयर द लिंक इज फिक्स्ड. तो कौन सी लिंक फिक्स्ड है हमारी लिंक 1 इज फिक्स्ड हियर. लिंक 1 इज फिक्स्ड. तो इंस्टेंटेनियस सेंटर विच आर फिक्स्ड will be on link 1 which is fixed. So I12 and I14 will be the fixed instantaneous center. Okay, so I12 and I14 will be fixed. Now second is permanent instantaneous center. So permanent instantaneous centers are the centers which are having whose location is continuously changing, but it is on the same joint. It will lie on the same joint. मतलब जैसे 2 और 3 का जो भी joint है उसके बीच में I23 है, तो I23 will be lie at the same joint. But if suppose this link is rotating in this direction, so the position of instantaneous center with respect to displacement will continuously change. It can change. So position with respect to displacement for I23 will change, but it will lie between these two links only, 2 and 3. Similarly, for 3 and 4, this is applicable. So this is, suppose this link is moving, so this 4 link is can be moved. So it can have oscillatory motion. So I3 and 4 will be on joint of 3 and 4, but it will define, we will define this as यहाँ पे मैं रब कर रही हूँ. If you have written, so it is well and good. So what we will do, we will I23 and I12. Okay, so we will extend this link in a particular direction. Similarly, we will extend I34 and I14 point in a particular direction, and wherever these points are meeting, that we will consider I13, because it is because these two links are parallel. So in this direction we are extending all the links or all the points. So this will become I13. अब यहाँ पे देखो, this is imaginary and it will be continuously moving with I23 and I34 if any one link is in rotation. Okay, so neither fixed nor permanent. Similarly, अगर हम ये वाली लिंक जो है, ये दोनों पॉइंट जो है एक्सटेंड करते हैं I23 and I34 and I14 and I12, both we will extend. So the point where both the extension line are intersecting, that we will consider as 4 and 2, so I24. So this is also imaginary and it will continuously displace with respect to rotation or with respect to motion. So this is also neither fixed nor permanent type of instantaneous center. Okay, तो यहाँ पर हमारे तीनों type of instantaneous center हो गए. The point which are on the fixed link are fixed instantaneous center. The point which are lying on the same joint, but it will continuously change its position with respect to displacement. So that is permanent type of instantaneous center. And the point which are imaginary as well as which are not having a fixed position, it will continuously change with respect to displacement of all other links. So that is neither fixed nor permanent type of instantaneous center. So hopefully these instantaneous center, types of instantaneous center you got. If you have any doubt, please let me know. ओके, क्योंकि अभी तक मेरे पास कुछ डाउट का कुछ भी आया नहीं है कि किसी को कोई डाउट है. ओके, सो दिस इज अबाउट द टाइप्स ऑफ इंस्टेंटेनियस सेंटर. नाउ लेट्स डिस्कस द लोकेशन ऑफ इंस्टेंटेनियस सेंटर. ओके, तो लोकेशन जो है वो हम 4 पार्ट में यहाँ पे डिफाइन करेंगे. किस तरह से लोकेशन डिफाइन करते हैं. सो द फर्स्ट टर्म वी आर कंसीडरिंग व्हेन an object is in translatory motion. Okay, when object is in translatory motion with respect to another fixed link. Okay, so this is link 1 and this is link 2, and both the links are in motion with, suppose one link is in motion with respect to another link, and any link, any of the link is not having any kind of rotation or any kind of curvilinear motion. Okay, so whatever point we are considering, suppose here we are considering point A, we are considering point B, we are considering point C, and suppose if we have velocity at point A, velocity at point B, and velocity at point C, VB, VC, VA. So suppose this is the direction of rotation and this is the direction of motion. So every velocity will have direction in the same direction, okay? Because this is the direction of motion and it will have same velocity. Each and every point will have the same velocity. Why? Because it is on the same link and there is no rotation. So the instantaneous center will be marked at infinite position. Right. So I suppose this is link 1, this is link 2. So I12 will be at infinite. Right. It will be at infinite. Now second is when two links are having turning pair. So suppose this is link, this is 1 and this is 2. So I12 will be at the joint only. So this is the joint where we will consider instantaneous center. Right. Now, the third is, suppose any link is having rotation about a fixed surface. Okay, so suppose this is link 1, this is link 2. So, the center of rotation of this particular link, the center of rotation of this particular link 2 is O. So, it will not be a instantaneous center. Why? Because it is continuously having motion. Okay, suppose in this direction it is having center motion. So the contact point will be the instantaneous center because this point is here first link is rotating with respect to अनदर लिंक ओके तो अगर हम व्हील भी कंसीडर करते हैं तो व्हील के केस में सेंटर ऑफ रोटेशन तो ये है सेंटर ऑफ रोटेशन इज फिक्स्ड बट द इंस्टेंटेनियस सेंटर इज कंटिन्यूअसली चेंजिंग ओके सो इंस्टेंटेनियस सेंटर जो है वो कॉन्टैक्ट पर ही रहेगा पोजीशन विल बी सेम बट विथ रिस्पेक्ट टू डिस्प्लेसमेंट इट विल चेंज इट्स पोजीशन ओके तो यहाँ पर कांटेक्ट पर इंस्टेंटेनियस सेंटर हम कंसीडर करेंगे बट अगर इस डायरेक्शन में हमारा जो ऑब्जेक्ट है वो मूव कर रहा है तो जितना भी डिस्प्लेसमेंट होगा तो उस पर्टिकुलर डिस्प्लेसमेंट के अलोंग हम उसकी पोजीशन चेंज करेंगे सेंटर ऑफ रोटेशन विल बी सेम सो दिस इज फॉर दिस पर्टिकुलर कंडीशन नाउ द फोर्थ इज if any object is moving inside the curvilinear path like this and that curve is fixed sorry in that case suppose this is our link 1 this is our link 2 so it will move in this direction or it will move in this direction so it will having this kind of motion with respect to one center so that center we will consider as the instantaneous center opposite to it if this object is moving over the outer surface like this so suppose this is 1 this is 2 link 2 and this is the path so instantaneous center will be the center of this curve okay center of curvature तो इस केस में हम लिख सकते हैं center of curvature तो जो भी हमारा इंस्टेंटेनियस सेंटर होगा सेंटर ऑफ कर्वेचर पर होगा बट हियर दिस पाथ इज स्ट्रेट and this circle is moving over this path so it will be on the point of contact only okay यहाँ पे condition change है यहाँ पे condition change है so this is about the location of instantaneous center for sliding it will be infinite for turning it will be at the point only तो ये वाले इसमें देखा था हमने यहाँ पे 4 टर्निंग पेयर है so at each and every point we will consider one instantaneous center as per the concept of turning pair if there is a rotational motion over the flat surface so the point of contact will be the instantaneous center if the flat surface is moving over the curve so the center of curvature will be the instantaneous center okay so this is representing the location of instantaneous center okay now here एक theorem है that theorem is called Arnold Kennedy theorem This is basically defined in terms of structure, where we are considering three links. Three links अगर हैं यहाँ पर, okay, so suppose this is link 1, this is link 2, and this is link 3. Okay, so this is 1, 2, and 3. So here if we mark the instantaneous center for these three links for this mechanism, so it will be I12, it will be I23, and it will be I13, right? तो यहाँ पर हमारे पास क्या है, we are considering three kinematic links. Okay, कभी भी link मत लिखना, हमेशा kinematic link लिखना. Okay, kinematic links 1, 2, and 3. So three instantaneous center for this will be I12, I13, and I23. Okay. So if we want to define the number of instantaneous center for this, number of instantaneous center n, IC लिख दिया मैंने, so n into n minus 1 divided by 2, so it will be 3 into 3 minus 1 divided by 2, तो ये हो जाएगा 3. तो तीन इंस्टेंटेनियस सेंटर हमने ऑलरेडी मार्क किए थे, तो तीन ही इंस्टेंटेनियस सेंटर आएंगे विच इज ऑन द टर्निंग पेयर, विच इज ऑन द पॉइंट ऑफ द जॉइंट ऑफ द टर्निंग पेयर, राइट. तो यहाँ पे तीन इंस्टेंटेनियस सेंटर हमारे मार्क हो गए. अब एज पर द कैनेडीज और आर्नोल्ड कैनेडी, if we are having three bodies which are moving relative to each other, it will have three instantaneous center which will lie on the same line. Okay, so यहाँ पे मैं लिख देती हूँ, if three bodies or links, if three bodies move relative to each other, and they have three instantaneous centers, if they have three instantaneous center, so all centers will lie on same line. Okay, मतलब यहाँ पे इंस्टेंटेनियस सेंटर अलग अलग पॉइंट पर है, I12, I13 एंड I23. तो यहाँ पर इस केस में जितने भी इंस्टेंटेनियस सेंटर होंगे वो सेम लाइन पर लाई करेंगे. बाय, बिकॉज दिस इज अ स्ट्रक्चर. देखो, एक तो three links are connected to each other, so it will not having any relative motion with each other, it will form a structure. तो अगर स्ट्रक्चर फॉर्म कर रहे हैं तो जिस भी डायरेक्शन में ये लिंक मूव करेंगे, कंप्लीट स्ट्रक्चर उसी डायरेक्शन में मूव करेगा. तो उस केस में जो इंस्टेंटेनियस सेंटर जो होगा वो हम तीनों जितने भी इंस्टेंटेनियस सेंटर होंगे वो एक रिजिड लिंक पर होंगे, क्योंकि हम उस पर्टिकुलर टर्म को हम एक ही उसमें एक ही लिंक में कंसीडर कर रहे हैं, एक ही स्ट्रक्चर में कंसीडर कर रहे हैं, राइट. सो हियर वी हैव 3 points at a same line for a structure, the structure which is having 3 links. How? देखो, जैसे यहाँ पर I12 है, तो I12 is lying on the same point, I13 is lying on the same point. Now if we are considering the third point I23, so it is not lying on the same point. In that case, how we can define that particular point is on the same link, right? So just a second. So here suppose देखो कैनेडी के अकॉर्डिंगली दीज 3 points should be on the same line, but अगर हम यहाँ पे कंसीडर करते हैं the point which is not lying on the same line. ओके, तो यहाँ पर अगर हमने I123 है जो वो अलग पॉइंट पर यहाँ पर जो है वो हमने यहाँ पे मार्क कर दिया. ओके, सो दिस पॉइंट विल हैव different velocities for this I12 and different velocity for this I13. okay, तो अगर हम I12 और I23 जो पॉइंट की बात करें तो जो velocity आएगी that will be in this direction, so V23 will be, and for this third link the velocity will be in this direction, v23. Okay, so here for I12 and I23, the velocity vector should be perpendicular to this, and for I23 and I13 line, the velocity vector should be perpendicular to this. Okay, and if we want this point on the same line, so in that case, these two velocity vector cannot be perpendicular to both the lines. Okay, so if we want both the points or this velocity vector perpendicular to both the length, okay, so it is not possible if we are considering the point on the same length. Okay, so Arnold Kennedy ने क्या कहा है, if three bodies move relative to each other, they have three instantaneous center at the same link or at the same line. Okay, so अगर हम यहाँ पर consider कर रहे हैं, in that case ये जो है velocity इस पर्टिकुलर लिंक की परपेंडिकुलर टू दिस, और दिस पर्टिकुलर वेलोसिटी विल नॉट बी दिस पर्टिकुलर वेलोसिटी v23 should be perpendicular to this. Okay, but practically it is not possible. In that case we usually consider all the instantaneous center at the same point. So hopefully ये चीज जो है वो आपको समझ में आई होगी. Okay, now अभी now how we can locate the instantaneous centers, how we can locate the instantaneous center. Okay, okay, hopefully ये चीज समझ में आए. If you have any doubt, please let me know. Okay, okay, जो भी वेलोसिटी है यहाँ पर इट शुड बी सेम. ओके, वेलोसिटी जो है इसकी चेंज नहीं होगी बिकॉज इट्स अ स्ट्रक्चर, राइट. तो वेलोसिटी, वेदर दैट वेलोसिटी दैट पॉइंट इज ऑन द लिंक 3 और ऑन द लिंक 2, इट शुड बी सेम. ओके, तो दोनों एक दूसरे के परपेंडिकुलर हो ही नहीं सकते, इसीलिए हम इसको यहाँ पर एक ही लाइन में कंसीडर करते हैं. ओके, सो दिस इज अबाउट द अर्नोल्ड कैनेडी थ्योरम. वैसे भी इतना इसको सोचने की जरूरत नहीं है, क्योंकि हमारे पास जो लिंक है, ऑल द लिंक्स आर थ्री नंबर ऑफ लिंक्स हैं, थ्री नंबर ऑफ लिंक्स हैं, सो इट विल ऑटोमेटिकली अ स्ट्रक्चर ओनली. तो जितनी भी वेलोसिटीज होंगी फॉर ऑल द इंस्टेंटेनियस सेंटर और फॉर ऑल द पॉइंट्स और फॉर ऑल द लिंक, इट विल बी सेम ओनली. ओके, तो हम उसको एक रिजिड स्ट्रक्चर कंसीडर करके चलते हैं. तो जैसे हम एक सेम लिंक लेते हैं और सेम लिंक पे नंबर ऑफ पॉइंट्स कंसीडर करते हैं, तो सेम लिंक पर नंबर ऑफ पॉइंट्स अगर हैं तो each and every point will have a same velocity because it is on the same rigid link, and structure is also considered as a rigid link. Okay, because it will not having any relative motion with respect to each other, so all the instantaneous center will lie on the same point. Okay, or sorry, same line only. So this is about Arnold Kennedy theorem. Now if we want to locate the instantaneous center for a mechanism which is having 4 links, okay, तो अगर हमारे पास number of links हैं 4, so we have to define the number of instantaneous center as n into n minus 1 divided by 2. तो ये आ जाएगा 4 into 4 minus 1 divided by 2, so it will be 6, right? So number of instantaneous center if we want to define, so we have to apply one method. So what this method is, so method का जो first part है, that is we have to define the number of links, then we have to define the number of instantaneous center. Okay, so first is define number of instantaneous center, right? Next, define the टोटल नंबर ऑफ इंस्टेंटेनियस सेंटर एट डिफरेंट पॉइंट. ओके, तो हम यहाँ पे डिफाइन करेंगे लिस्ट ऑफ इंस्टेंटेनियस सेंटर. ओके, लिस्ट ऑफ इंस्टेंटेनियस सेंटर. ओके, तो सपोज अगर मैंने यहाँ पे लिंक्स मार्क कर दिए 1 2 3 4, तो 1 के लिए कितने कॉम्बिनेशन बनेंगे हमारे, I12 I13 I14, राइट. 2 के लिए कितने कॉम्बिनेशन बनेंगे, I23 I24, और 3 के लिए कितने कॉम्बिनेशन बनेंगे, I34. 4 के लिए कितने कॉम्बिनेशन बनेंगे, 41 42 43, तो 14 ऑलरेडी है, 24 ऑलरेडी है, 34 ऑलरेडी है. ओके 3 के लिए कॉम्बिनेशन अगर हम 2 के साथ बनाए तो 2 3 ऑलरेडी है, और 1 के साथ बनाए तो 1 3 ऑलरेडी है। ओके सो इस तरह से कितने कॉम्बिनेशन हो गए हमारे, 1 2 3 4 5 एंड 6, तो 6 नंबर ऑफ इंस्टेंटेनियस सेंटर के कॉम्बिनेशन हमने यहाँ पे डिफाइन कर दिया, राइट। यहाँ पे कॉम्बिनेशन डिफाइन कर दिए। अभी यहाँ पे एक डायग्राम ड्रॉ कर लेते हैं। ओके सो 1 2 3 and 4. So this is our link 1, this is our link 2, this is our link 3 and this is our link 4. Okay, so 4 link है. If it is a mechanism तो 1 link should be fixed, right? तो instantaneous center हम मार्क करेंगे सारे combination 1 4 1 2 2 3 and 3 4, राइट। तो 4 तो मार्क हो गए, राइट। अभी 4 मार्क कर दिए तो 2 तो हमारे फिक्स्ड इंस्टेंटेनियस सेंटर हो गए, 2 परमानेंट हो गए। तो I14 और I12 हमारे फिक्स्ड इंस्टेंटेनियस सेंटर बिकॉज इट इज ऑन द फिक्स्ड लिंक। I34 एंड I23 जो है इट इज चेंजिंग विथ रिस्पेक्ट टू चेंजिंग इट्स पोजिशन विथ रिस्पेक्ट टू डिस्प्लेसमेंट। तो ये इस अपनी पोजिशन जो है अकॉर्डिंग टू मोशन ऑफ एनी अदर लिंक इट विल चेंज। ओके सो 4 हमारे जो इंस्टेंटेनियस सेंटर हैं वो मार्क हो गए। नाउ वी हैव टू मार्क द अदर 2 इंस्टेंटेनियस सेंटर। देखो मैं पहले भी बता चुकी हूँ, हमें क्या करना है, यहाँ से दोनों लिंक्स को एक्सटेंड करना है, चारों लिंक को अकॉर्डिंग टू इंक्लिनेशन जो है वो हमें एक्सटेंड करना है, तो हमारे पास वो पोजीशन आ जाएगी। ओके सो 1 4 और 1 2 1 4 1 3 4 को हम एक्सटेंड करेंगे और 1 2 और 2 3 को एक्सटेंड करेंगे, तो ये आ जाएगा हमारा, कौन सा आ जाएगा, 2 3 एंड 1 आर इन पैरेलल, तो 1 3 आ जाएगा। सिमिलरली इस डायरेक्शन में हम इन लिंक्स को एक्सटेंड करेंगे तो हमारे पास अनदर कॉम्बिनेशन आ जाएगा। 2 और 4 पैरेलल में है तो ये I24 आ जाएगा। तो 6 हमारे मार्क हो गए, बट ये पॉइंट आएंगे कहाँ से, ये कैसे हमें पता चलेगा? इसके लिए अर्नोल्ड कैनेडी थ्योरम ही हम यहाँ पर अप्लाई करेंगे। सपोज हमारे पास कितने नंबर ऑफ लिंक है, 4 लिंक हैं। सो हियर वी विल ड्रॉ अ सर्कल, और हम चारों लिंक जो हैं वो, या जो चारों पॉइंट जो हैं लिंक के, 4 जो टर्निंग पेयर्स हैं वो यहाँ पे मार्क कर देंगे, या फिर चारों अकॉर्डिंग टू पोजीशन वी विल ड्रॉ ऑल द पॉइंट्स इनसाइड द सर्कल। ओके तो अब अगर हमने यहाँ पे मार्क कर दिया 1 2 3 एंड 4, इस तरह से हमने मार्क कर दिया, राइट। तो these are representing what? These are representing the instantaneous center 1 4 3 4 2 3 and 1 2, राइट। तो ये 4 इंस्टेंटेनियस सेंटर तो हमारे पास ऑलरेडी आ गए हैं। अब हम क्या करेंगे, वी विल ड्रॉ द डायगोनल ऑफ द स्क्वायर, या फिर जो हमारा रेक्टेंगल है या जो भी स्क्वायर हमारा आया है उसके हम डायगोनल ड्रॉ करेंगे, जो अपोजिट एंड है, अपोजिट पॉइंट है, उनको ज्वाइन कर देंगे। ओके तो अभी देखो जो ज्वाइन लाइन जो ज्वाइन हो रही है वो कौन सी पॉइंट्स को ज्वाइन कर रही है, 2 4 और 3 1। तो यहाँ पर हमारे पास जो अनदर कॉम्बिनेशन थे वो कौन से थे, I13 और I24। तो ये वाली लाइन जो है वो रिप्रेजेंट कर रही है अनदर इंस्टेंटेनियस सेंटर I24 एंड I13। बट इसको हम मार्क कैसे करेंगे, अभी देखो ये वाली लाइन देखो, दिस लाइन, ओके लेट मी चेंज द कलर। सो ये वाली जो लाइन है, दिस लाइन, तो यहाँ पे एक ट्राइंगल क्या बन रहा है, एक ट्राइंगल 1 2 4 है और एक ट्राइंगल 2 3 4 है। तो अगर हम ट्राइंगल 1 2 4 में देखें तो दिस 2 and 4 is having another two line, this triangle is having another two line 1 and 2 and 1 and 4। ओके तो अगर हमें 2 and 4 मार्क करना है, so we have to consider 1 and 2 and 1 and 4 दिस पॉइंट, राइट। तो ये जो हमारा पॉइंट है इस लाइन को हम कंटिन्यूअसली एक्सटेंड करते जाएंगे, राइट। सिमिलरली आई दिस 2 and 4 is also having another triangle दिस इज द कॉमन लाइन फॉर बोथ द ट्राइंगल 2 3 4। तो यहाँ पर 3 4 और 2 3 जो लाइन है उसको हम एक्सटेंड करते जाएंगे. सो दिस लाइन वी हैव. So on the basis of these two triangle, we can define the location of I24. देखो 2 4 कॉमन है तो 1 4 और 1 2 हम एक साइड लेंगे, उसको एक्सटेंड करते जाएंगे, और 4 3 और 2 3 को हम लेंगे और इसको एक्सटेंड करते जाएंगे. wherever it is intersecting, I24 will be there. Similarly, for 1 3 we have two triangle 1 2 3 and 3 4 1. This is the triangle. तो एक ये ट्राइंगल हो गया, एक ये ट्राइंगल हो गया. इन दोनों के पॉइंट्स हम यहाँ पे मार्क करेंगे 1 2 एंड 2 3. तो 1 2 एंड 2 3, 1 2 एंड 2 3, इसको एक्सटेंड कर देंगे. सिमिलरली 1 4 एंड 3 4. तो 1 4 एंड 3 4, 1 4 एंड 3 4 जो है इसको हम एक्सटेंड करेंगे. एंड वेर एवर बोथ द लाइन्स आर इंटरसेक्टिंग, वी विल मार्क the sixth instantaneous center. So in this manner, we will mark all the instantaneous centers. Okay. So this is not only applicable for 4 links. Suppose if we have more than 4 links, more than 5 links, 6 links, 7 links. So accordingly, we have to mark or we have to draw the polygon, and on that basis we can define the instantaneous center. अगर हमारे पास 5 लिंक है तो हम पेंटागन ड्रॉ कर लेंगे. अगर 6 लिंक है तो हेक्सागन ड्रॉ कर लेंगे, और अकॉर्डिंगली वी विल मार्क इंस्टेंटेनियस सेंटर. देखो सपोज अगर हमारे पास 6 लिंक है तो 6 इंटू 6 माइनस 1 डिवाइडेड बाई 2. तो ये क्या हो जाएगा, 2 3 6 एंड दिस इज 5, सो 15. सो अल्टीमेटली वी विल हैव 15 नंबर ऑफ इंस्टेंटेनियस सेंटर. तो अगर हमारे पास 6 लिंक है और अगर हम 6 लिंक एक सर्कल में ड्रॉ करते हैं तो उसके कितने नंबर ऑफ कॉम्बिनेशन बनेंगे वो हमें डिफाइन करना पड़ेगा. सपोज यहाँ पे जो भी हम कॉम्बिनेशन बनाएंगे, लाइक दिस, लाइक दिस, लाइक दिस, जो भी हम कॉम्बिनेशन बनाएंगे तो नंबर ऑफ ट्राइंगल्स जो है, सो ओके लाइक दिस. So for this link we will have this triangle. Okay, for this link we will have this triangle. For this link we will have the same triangle. So accordingly we will define the instantaneous center. Okay, so hopefully ये जो चीज़ है आपको समझ में आई होगी. If you have any doubt, please let me know. I will clear all your doubts. अगर कहीं पर भी पीछे कुछ भी समझ में नहीं आया है, आप प्लीज कमेंट कर दीजिए, और यू कैन मेल योर doubts on coursecreel@gmail.com, or we have our official number as 937227663. So you can WhatsApp on that particular number also if you have any doubt. But please mention your doubt and the related lecture also. Okay, like the lesson 5 velocity and mechanism. So I will solve your doubt accordingly. Okay, so thank you so much for watching this video, today's video. If you like the video, please share it, and if you are not the subscriber, please subscribe it, and you can refer these lessons to your friends also for their benefits. So thank you so much. See you in next class. Good night. Okay, so just let me check. Okay, so till now we don't have